Welcome to Lucid Mind Chemistry channel. In this video, I have compiled questions related to Le Chatelier Principle applications such as effect of temperature, pressure, catalyst and concentration on position of equilibrium and yield and rate of chemical reaction. For similar topics and question timestamps, read video description. Question 3. The catalyzed formation of ammonia by Haber process can be represented by the equation shown. This is an exothermic process, so therefore the enthalpy change is negative. Which change in conditions will increase both the rate of formation and the equilibrium yield of ammonia? So we have to find out what changes the rate and also the equilibrium yield. A says decrease in the temperature. Now as the reaction is exothermic, so in order to obtain greater yield we need lower temperature. But what happens that when we decrease the temperature, actually the reaction slows down. So therefore the rate of formation will also decrease with the decrease in temperature. B is increase in the temperature. If we will increase the temperature for an exothermic reaction, the reaction is going to be moving backwards, which actually decreases the equilibrium yield of ammonia, so therefore B is also not the option. C says increase in the pressure. Now let's find out the number of moles. We have 1 mole of nitrogen gas, 3 moles of hydrogen gas and 2 moles of ammonia gas are present in the product. We know that whenever the pressure is increased, the reaction moves from more number of moles to less number of moles, or in this case more product is formed. And also pressure can also increase the rate of reaction because the molecules just come close together and there are more number of effective collisions. So therefore increase in pressure can increase both the rate and also the equilibrium yield of ammonia. D says increase in the surface area of the catalyst. Now increasing the surface area of the catalyst does not increase the equilibrium yield, it only increases the rate of formation. So therefore the only option is C. Question number 10. X and Y react together to form Z in a reversible reaction. The equilibrium yield of Z is lower at higher temperature. The equilibrium yield of Z is lower at lower pressure. Which equation could represent this reaction? As we can see that Z is the product and X and Y are the reactants in this equilibrium. Now at higher temperature the concentration or equilibrium yield of Z becomes lower. It means that the reaction is exothermic. This is because for exothermic reaction the temperature is the product, so if you are increasing the temperature the equilibrium will move in the backward direction, so product will become low. So it should be either negative 100 or this one, as both are exothermic. Now moving towards the second option, the equilibrium yield of Z is lower at lower pressure. As we know that higher pressure makes the equilibrium go from more number of moles to less number of moles, while lower pressure will make the equilibrium move from less number of moles to more number of moles. Let's find out the number of moles. We have 1 plus 1, so 2 moles of reactant and 1 mole of product. So this reaction can go from less number of moles to more number of moles. So A could be correct. In C we can see that we have 2 number of moles of reactants and 2 number of moles of product. So as the number of moles are equal, so there will be no effect of pressure on the equilibrium yield. So C is incorrect. Correct answer is therefore A. Question 34. The equation represents an equilibrium reaction. Ammonia reacts with oxygen to form nitrogen monoxide with water. The enthalpy change is negative 900, so it means it is exothermic reaction. What would increase the concentration of NO at equilibrium? NO is the product. Number 1, a reduction in the reaction temperature. This is true because when temperature is reduced for exothermic reaction, the equilibrium moves in the forward direction and more product will be formed. Part 2, the use of suitable catalyst. Now catalyst only decreases the activation energy and the rate of reaction is increased in both forward and backward direction. The concentration of any reactant and product is not affected. Part 3, an increase in total pressure. Now pressure depends on the number of moles. We have 5 and 4, 9 moles on the reactant side and 10 moles on the product side. So when pressure is increased, the reaction will move from more number of moles to less number of moles. So the concentration of product will decrease. As only option 1 is correct, the answer is D. Question 10. In a particular reversible reaction, the yield of product is increased if the temperature is increased, if the pressure is decreased. Which equation could describe this reversible reaction? Now we know that if the temperature is increased for endothermic reaction, the reaction will go in the forward direction and more product is formed. So the reaction must be endothermic. So it could be this one or this one, as the enthalpy change is positive for endothermic reaction. Second thing is pressure. Now we know that when pressure is decreased, the reaction will move from less number of moles to more number of moles. So it means that the number of moles of product should be greater than the number of moles of reactant. So in A we have 1 mole of CH4, 1 mole of water, 3 moles of hydrogen gas and 1 mole of carbon monoxide gas. Now the number of moles of product is greater than the number of moles of reactant. So therefore the reaction will move from less number of moles to more number of moles, or we can see that more product is formed. So therefore the yield of product is increased. So A is correct for both options. For part D, we can see that we have more number of moles of reactant and less number of moles of product. So the reaction will move in backward direction upon decreasing pressure. So therefore the yield of product will decrease. As we are looking at the increased yield, so therefore D is incorrect. Correct answer is therefore A. Question 34. Methanol can be produced industrially by reacting carbon monoxide with hydrogen. This is the equation. Enthalpy change is negative. The process can be carried out at 4 exponential 3 kilopascals and 1150 Kelvin temperature. Which statement about this reaction are correct? Number 1. Increasing the temperature will increase the rate of reaction because more effective collisions will occur. Now what happens when temperature is increased? The kinetic energy of molecule also increases. So number of collisions will increase and it is possible that effective collisions are also increased. So it results in increasing the rate of chemical reaction. So therefore option 1 is correct. Option 2. Lowering the temperature will reduce the rate of reaction because the forward reaction is exothermic. Now lowering the temperature does reduce the rate of reaction, but this reason given is incorrect. If the forward reaction is exothermic, the lowering temperature will shift the equilibrium in the forward direction. It will also reduce the rate of chemical reaction. So 2 is incorrect. 3. Increasing the pressure will reduce the rate of reaction because there are a large number of moles on the left side of the equation. Now increasing the pressure makes the gas molecules come close together and the rate of reaction will also increase. So 3 is incorrect. As only option 1 is correct, so therefore answer is D. Question 14. Silver nitrate aqueous is added to a solution of a halide ion X negative and aqueous ammonia is then added. The ionic equations for the two reactions that occur are shown. This is the first equilibrium reaction and this is the second equilibrium reaction. Which statement is correct? A. The position of equilibrium 1 lies to the left when X negative is iodide ion. When X negative is iodide, what happens that silver iodide is formed, AgI. So as AgI is insoluble in aqueous ammonia, so therefore AgI will be precipitated out of the solution in solid form and the reaction will move in the forward direction. So we can say that the equilibrium will lie to the right rather than left. So A is incorrect. B. Increasing the concentration of ammonia causes the position of equilibrium 1 to move to the left. When concentration of ammonia is increased, so we are actually increasing the amount of product in second equilibrium. So when product is increased, the concentration of Ag plus will reduce as it is converted into product. So when Ag plus concentration is reduced, what happens that the first reaction will move backward as Ag plus is the reactant. Because for an equilibrium reaction, if you decrease the amount of reactant, the reaction will move in the backward direction. So B is correct. C. Kc for equilibrium 2 is larger when X is Cl negative than when X is iodide. When X negative is Cl, then AgCl is formed, which is soluble in aqueous ammonia. So it will convert into ions Ag plus and Cl negative. But when X is iodide, so then silver iodide is formed, which is insoluble. So because of AgCl, what happens that the silver ion concentration will increase. As for equilibrium 2, Kc is equal to the concentration of product, which is silver ammonia, divided by the concentration of reactant, which is silver aqueous and ammonia. So as we can see that the value of Kc is inversely proportional to the concentration of Ag plus. So when Ag plus will increase, the value of Kc will decrease. So when X is Cl negative, then Kc for equilibrium 2 is smaller. So C is incorrect. Option D, equilibrium 2 is a redox reaction. In redox reaction, oxidation and reduction occurs. As we can see that the charges on the element has not changed. Silver is still Ag plus, nitrogen is still -3 on the reactant end product, and hydrogen is +1. So there is no change in oxidation state, so D is incorrect. The answer is therefore B. Question 34. The stoichiometry of a catalyzed reaction is shown by the equation below. This is the equation. P and Q react to form R and S. Two experiments are carried out in which the amount of R is measured. The results are shown in the diagram. We can see that in experiment 1 the amount of R is greater. In experiment 2 the amount of R is less. Also experiment 1 is more steep as compared to experiment 2. Which changes in conditions could explain the results shown? 1. A lower pressure was used in experiment 2. Let's look into the number of moles of reactants and products. So in reactant we have 1 mole of P and 1 mole of Q. So in total there are 2 moles of reactant that are present as gases. And in product we just have 1 mole of R, while S is in liquid form, so there is no effect of pressure on S. So only 1 mole will be considered in the product. Now we know that when pressure is increased, the equilibrium moves from more number of moles to less number of moles. While in option 1 a lower pressure was used, it means that the equilibrium will move in the backward direction and the amount of R formed will be less. As in experiment 2, we can see that the amount of R is less as compared to experiment 1. So first statement is correct. Option 2. A different catalyst was used in experiment 2. Now, a catalyst increases the rate of reaction by providing alternate pathway. It is not necessary that when different catalyst is used, the rate of reaction will remain same. So there could be different catalysts present in experiment 1 and experiment 2. So option 2 could be correct. 3. Product S was continuously removed from the reaction vessel in experiment 2. As product S is continuously removed from reaction vessel, so then what will happen that upon removal of product, the reaction should move in the forward direction and more amount of R should be produced. While in experiment 2, the less amount of R is present, so therefore option 3 is incorrect. As option 1 and 2 are correct, so therefore answer is B. Question 10. The decomposition of sulfur trioxide gas is a dynamic equilibrium. Sulfur trioxide gas converts into sulfur dioxide gas along with oxygen gas. What happens when the pressure of the system is increased? As we know that in gases, what happens when we increase the pressure, the molecules come close together and there are more effective collisions. And the rate of reaction also increases. Let's talk about the position of equilibrium. We have 2 moles of the reactants and we have 2 plus 1 moles of products. So whenever pressure is increased, the gaseous equilibrium reaction moves from more number of moles to less number of moles. So therefore by increase in pressure, the equilibrium will move towards the left side. Let's move towards the option A. The rate of reaction will decrease and the position of equilibrium will move to the left. As the rate of reaction will increase, so therefore this is incorrect. In B, the rate of reaction will decrease. Again, this shows a decrease, so therefore this is also incorrect. In C, the rate of reaction will increase. This is true. And the position of equilibrium will move to the left. As we know, it will move from more number of moles to less number of moles, which is to the left. So C seems correct. Indeed, the rate of reaction will increase and the position of equilibrium will move to the right. So this is incorrect. So the only correct option is C. Question 11. Hydrated aluminum ions undergo the following chemical reaction. Which statement about this reaction is correct? H2O liquid and AlH2O5OH plus 2 aqueous are conjugate acid-base pair. Now, 2 things are acid-base pair only when they differ by H positive. For example, we can say that H2O liquid and H3O positive are acid-base pair, as the difference is only of H positive ion. As in H2O liquid and this compound, there is a difference of more than one H plus ion, so therefore this is not a conjugate acid-base pair. B. H2O liquid is acting as an acid as it is donating H positive ions. As in the chemical reaction, we can see that H2O liquid converts into H3O positive aqueous. So whenever H2O liquid converts into H3O positive aqueous, it means it is gaining H positive ion. So H2O is actually accepting H plus, so therefore H2O is not an acid, it will behave as a base. So this is also incorrect. Part C, if OH negative aqueous is added, the equilibrium will move to the right. As OH negative is basic in nature, so therefore what will happen that OH negative will react with H3O positive in a neutralization reaction and it will form H2O. So the concentration of H3O positive will decrease, and as H3O positive is the product, so therefore the decrease in the amount of product makes the reaction go in the forward direction. So the equilibrium will move to the right. This is correct. D. Kc varies as the pH is varied. Kc represents the equilibrium constant expression, and we know that Kc only changes with the change in temperature. And it is not affected by pH or pressure or concentration. So therefore correct option is C. Question 11. The reaction between sulfur dioxide and oxygen is reversible. This is the reversible reaction and enthalpy change is negative, which means it is exothermic reaction. Which conditions of pressure and temperature favor the reverse reaction? First is pressure. Pressure depends on the number of moles. We have 3 moles on the reactant side, 2 of SO2 and 1 of oxygen, and 2 moles on the product side. Now we know that at higher pressure the equilibrium will move from greater number of moles to less number of moles, or in forward direction. So it means that pressure should be kept low if we want the reverse reaction. So pressure should be lower. Second thing is temperature. For temperatures you have to see whether the reaction is exothermic or endothermic. For exothermic reaction, if we increase the temperature, the reaction will move backward or in reverse reaction, so therefore temperature should be high. So for reverse reaction, pressure should be low and temperature should be high. The answer is therefore C. Question 12. Which statement about the effect of a catalyst on a reversible reaction is correct? We know that catalyst reduces activation energy of a chemical reaction. The reaction therefore becomes faster. A. The activation energy of the forward reaction stays the same. This is incorrect because the activation energy of the forward and backward both reactions is reduced. B. The composition of the equilibrium mixture stays the same. This is true because catalyst does not affect the composition of equilibrium mixture, it just reduces time to attain equilibrium. C. The rate of backward reaction stays the same. Again, this is incorrect because the rate of backward reaction also becomes fast as the rate of forward reaction becomes fast by the presence of catalyst. D. The value of equilibrium constant changes. This is also incorrect because equilibrium constant is only affected by temperature. It is not affected by anything else. Correct answer is therefore B. Question 5. The gases X and Y react to form Z. This is the equilibrium expression. An equilibrium mixture of these 3 gases is compressed at constant temperature. What will be the changes in the mole fraction of Z and in Kp? Mole fraction is the portion of moles of Z in equilibrium. Now we can see that we have 1 mole of X and 1 mole of Y, which combine to form 1 mole of Z. Now the number of moles of reactant is 2 while the number of moles of product is 1. So at higher pressure, when the gases is compressed, what happens that the equilibrium will move in the forward direction from more number of moles to less number of moles. So therefore the mole fraction of Z will increase. Second thing is Kp. Now we know that Kp or Kc is only affected by temperature. It is not affected by concentration or pressure or catalyst. As temperature is constant, so therefore Kp will not change. The answer is therefore B. Question 34. The temperature of a reversible gas phase reaction is increased. Which statement are always correct? Part 1. More product is present at equilibrium. Now this is true only for endothermic reactions. As for endothermic reaction, when temperature is increased, what happens that more product will be formed as the reaction moves in the forward direction. But this will be wrong in case of exothermic reaction, because in exothermic reaction the reaction will move in the backward direction, so less product will be formed. So option 1 is not always correct, so therefore it is wrong. 2. The average speed of the particles increases as we are increasing the temperature, so therefore what happens that it will increase the kinetic energy of the molecules of both reactants and products, so therefore average speed will also increase. Number 3. There are more successful collisions per unit time. As we are increasing the temperature, the kinetic energy is increased, number of collisions will increase, so therefore there is a chance that more successful collisions will also increase. As option 2 and 3 are correct, the answer is therefore C. Question 11. Nitrogen and hydrogen can react together to form ammonia. The formation of ammonia is exothermic reaction. The rate and yield of the reaction can be altered by changing the conditions under which reaction is carried out, which shows the effects of adding iron to the mixture and increasing the temperature. First one is addition of iron and second is the increase in temperature. As iron is used as catalyst, so it will lower the activation energy. Part A, it has no effect on the equilibrium yield. This is true because catalyst does not increase or decrease the yield, it only increases the rate of reaction in both forward and backward directions. Part B, increases the equilibrium yield. No. Part C, increases the equilibrium yield. Again, it is incorrect because it does not have any effect on the equilibrium yield. D, increases the rate of chemical reaction. Now, as the reaction is exothermic, so therefore increasing the temperature will decrease the yield of product. So it reduces the equilibrium yield of ammonia. This is correct. Increases the equilibrium yield. This is incorrect. Increases the rate of chemical reaction. This is true as kinetic energy is increased. And last one is that it has no effect on the equilibrium yield. This is untrue because this is exothermic reaction and the reaction will move in backward direction. Correct answer is therefore A. Question number 10. Hydrogen iodide gas decomposes reversibly, producing iodine vapor and hydrogen. The enthalpy change is also given, which is plus 12 kilojoules per mole. The position of equilibrium for this reaction may be altered by changing the external conditions. Which row correctly describes the change in position of equilibrium? First is the increasing the pressure and second is increasing the temperature. Let's look into the number of moles of the reactants and products. So we can see that 2 moles of HI gas are decomposing. So it is 2 moles on the reactant side and 1 mole of iodine and 1 mole of hydrogen gas is formed. So therefore there are 2 moles of product that are being formed. As the number of moles of reactant and number of moles of product is equal, so therefore there will be no effect of pressure on the position of equilibrium. This is because pressure will affect the reactant and product in equal manner, so therefore there is no change. Second thing is the increasing of temperatures. As we can see that the reaction is endothermic. So for endothermic reaction, if temperature is increased, what happens that the reaction moves in the forward direction and the position of equilibrium also moves to the right. This is because endothermic reaction require energy in order to convert into products. So if you are increasing the temperature, the reaction will move forward. If you are decreasing the temperature, the equilibrium will move backward. The answer is therefore C. Thanks for watching. If this was useful, please do like, subscribe and share.